If you melted this blade down today, you probably couldn't make it again. Not exactly. Not the same way. And that's the part no one likes to say out loud, because Damascus steel wasn't just strong. It behaved differently, in ways modern steel still struggles to replicate cleanly. And the strangest part isn't the edge, it's the surface. Those flowing, almost liquid patterns don't look forged. They look like they grew there, as if the metal organized itself from the inside out. For a long time, people assumed it was decoration, something added after the fact. But under magnification, those patterns aren't sitting on top. They're embedded deep inside the structure, tied to how the steel actually formed. And that's where things start to break our expectations. Because steel is supposed to be repeatable, controlled, predictable. You follow the same process, you get the same result. But here, the smallest change breaks everything. Slightly different ore, a subtle shift in heat, a few seconds too long, and the pattern disappears. Not weaker, not distorted, just gone. That shouldn't happen. Not in something humans once made well enough to leave behind real blades. So something else was happening. Not just shaping, but balancing. Like the material itself was sitting on a narrow edge between order and collapse. And only when everything aligned just right, the pattern appeared. Not designed line by line, revealed. And if that's true, then this wasn't just craftsmanship. It was a process the maker never fully controlled. Which leads to a quieter, more uncomfortable thought. Maybe the secret of Damascus steel was never a formula that got lost. Maybe it was a set of conditions so fragile that once broken, no one could ever bring them back the same way again. And this is where it stops making sense. Because by every modern standard, Damascus steel should be worse, not better. If you build steel today, you remove impurities. You make it clean, uniform, predictable, because that's how you prevent failure. And yet these blades were the opposite, full of tiny inconsistencies, irregular carbon clusters, uneven internal structures, the exact things engineers are trained to eliminate. And somehow, those flaws didn't weaken the blade. They changed how it failed, or more accurately, how it refused to fail. That's the part people don't expect. Because when stress hits modern steel, it travels cleanly, directly, until something gives. And when it fails fast. Clean, sudden. But inside Damascus steel, stress doesn't move that way. It gets interrupted, redirected, slowed down by those internal patterns. Almost like cracks are being guided away, instead of allowed to tear straight through. And that creates a strange effect. The blade doesn't just resist force, it absorbs it differently. Which sounds impressive until you realize something uncomfortable. We didn't design it that way, at least not intentionally. Because when modern researchers try to recreate this, they can copy the pattern, they can approximate the chemistry, but the behavior still isn't the same. And that's where the contradiction hits. We understand more about steel than ever before, and yet we can't reliably reproduce something that existed hundreds of years ago without losing part of what made it unique. That shouldn't happen. And here's where it gets worse. Some of the original materials, specific ores, trace elements like vanadium or tungsten in tiny natural amounts, may no longer exist in the same way. Which means the process wasn't just technique. It was environment, geography, chance. A combination so specific that once it disappeared, it couldn't simply be written down and recovered. So now the question shifts again. Because this isn't just lost knowledge. It might be lost conditions. And if that's true, then even if you knew exactly what to do, you still might not be able to do it, which leaves something unresolved. Maybe Damascus steel wasn't a perfect technology at all. Maybe it was something far more unstable, something that only worked when everything went right. And maybe that's the part we keep missing, because we assume knowledge lives in books, in formulas, in things you can write down and pass forward. But for most of history, it didn't live there at all. It lived in hands, in repetition, in habits so ordinary they didn't seem worth recording. A blacksmith wouldn't describe temperature in exact numbers. He would see it in color, in the way the metal glowed just before it changed, in the sound it made under the hammer, in how it resisted or didn't. And that kind of knowledge doesn't translate cleanly. It fades the moment the hands that carried it are gone. And maybe that's why Damascus steel feels less like a lost formula and more like a lost way of feeling. Because even if two smiths followed the same steps, the outcome wouldn't be the same. One waits a second longer. When one strikes slightly differently, one cools the blade in a way that can't quite be measured. And suddenly, the pattern changes or disappears, which suggests something uncomfortable, because it means the material wasn't just responding to controlled variables. It was responding to judgment, to timing, to decisions made in the moment. Things we don't usually consider part of technology anymore. And yet, maybe they were. There are records of workshops where techniques were guarded, not written down, passed from master to apprentice over years, sometimes decades, not because the process was complicated on paper, but because it couldn't be reduced to paper at all. And once that chain broke, once the last person who felt the process was gone, the knowledge didn't get archived. It dissolved. And that creates a strange gap. Because today, we can analyze the steel at a microscopic level. We can map its structure, identify the carbides, trace the composition. But that only tells us what exists, not how it came to exist that way. Not the sequence of small, almost invisible decisions that led there. It's like finding the final shape of something without ever seeing it form. And maybe that's why recreations always feel slightly off, too controlled, too intentional. Because modern processes aim for certainty, while whatever created Damascus steel may have depended on something closer to controlled uncertainty. Which sounds like a contradiction, until you realize older crafts often lived in that space, where the goal wasn't to eliminate variation, but to work with it, to guide it just enough, without forcing it completely. And if that's true, then the real loss wasn't the steel itself. It was the way of thinking that allowed it to exist in the first place. And that way of thinking comes with a cost we don't usually talk about, because systems built on control give us consistency, scale, reliability. But they also remove something quieter, something harder to measure. They remove dependence on the person. Because modern steel doesn't care who makes it. That's the point. It's designed to behave the same way every time, under the same conditions, no matter who is standing there. And that's powerful. But it also means something else has been stripped away. Variability, judgment, those small human adjustments that once shaped the outcome in ways we didn't fully understand. Damascus steel seems to have lived on the other side of that trade-off. It may have been stronger in certain ways, but only under the right hands, the right materials, the right moment. Remove any part of that, and the result changes, which makes it fragile, not as a blade, but as a system. And fragile systems don't survive time. So what we're left with isn't just a lost technique. It's the shadow of a process that couldn't be standardized, couldn't be industrialized, couldn't be scaled without losing what made it work in the first place. And that leads to a quiet conclusion, or maybe not even a conclusion. Because we like to believe progress replaces the past cleanly. That better knowledge makes older methods irrelevant. But Damascus steel doesn't fit that story. It sits in an uncomfortable space, where something may have been gained, and something else quietly disappeared. Not because it was impossible to understand, but because it wasn't practical to keep. Perfect systems break perfectly. And maybe that's the part that lingers, because if a material once existed that depended on imbalance, on variation, on conditions we can't fully recreate, then the real question isn't just how it was made. It's whether we would even choose to make it that way again, if we could.